Okay, good day everyone. Today we will be discussing about innovations in the reduction of air pollution. So we have three parts for this. We have for the SOx or sulfur oxides, NOx nitrogen oxides, and for the PM particulate matters and carbon dioxide. Okay, so first video we will be discussing about SOx. Okay, so the motto for today: keep calm, engineers will save the world. So are they superhero heroes? I don't know. Okay, so engineers creating tomorrow. Okay, next. So today we will be more focused on the part of the engine, which is the exhaust system, the fuel system, because these are the parts that contribute mostly on the air pollution of the engines. Okay, so SOx emissions. So sulfur contained in fuel oil oxides during the combustion. So SO2 and SO3 are collectively known as SOx, sulfur oxide emissions. So sulfur oxides is the major component of SOx in the exhaust gases. So SOx is a major contributor to acid rain and smog. Okay, so these are uh, the effects of the acid rain. Okay, so most ships contribute to the SOx emission in the atmosphere. So this SOx makes the higher cloud droplet concentration and increased reflectivity. So to lessen the effect of SOx, so ships are now making things, and even industry are doing something to lessen the effects of sulfur oxide. So with oxygen, H2O, and combined to sulfur oxide, so you will create acid rain, fog snow, and wet precipitation. So this is the chemical. Okay. Okay, first we talk about particulate matter. So particulate matter consists of incomplete combustion elements known as soot. So those the black soots that come out from our chimneys, those are um, particulate matter. Oxidized metal elements from fuel and lube oil known as ash. So ash is also a particulate matter. Okay, so these are a combination of different of soot, hydrocarbon, sulfate, hydrated sulfate, sulfuric acid, vapor hydrocarbon. So all these particulate matters are exhausted to the atmosphere. We also have black carbon or BC. So is a form of ultrafine particulate matter. It is estimated that 22% of the black carbon is emitted by shipping, so by the shipping industry. So it contributes to the accelerated ice loss in the Arctic. So in 2021, the IMO adopted a resolution to urge ship owners to use diesel or alternative fuels when sailing in the Arctic. So black carbon's warming effect is at least 3 times higher in the Arctic. So rise in Arctic shipping traffic is bad news for black carbon emissions. Okay. For MARPOL Annex 6 Regulation 18 bunker delivery note, so shall contain the sulfur content in percent mass per mass, shall be kept on board. This is mass per mass. Shall be kept on board the ship and available for inspection. shall be retained for a period of 3 years after the fuel oil has been delivered on board. Shall be accompanied by a sealed and signed representative sample of the fuel oil delivered. So sample to be retained on board for a period of not less than 12 months. Okay. So nga po, annex regulation 14, sulfur oxides and particulate matter. The sulfur content of any fuel oil used on board ship shall not exceed 0.50%. So in emission control areas, ECA areas, the sulfur content shall not exceed 0.10%. So emission control areas. So these are the emission control areas. Those with the highlights. Okay, so MARPA Annex 6 Regulation 14.6 changeover procedure entering or leaving SECA areas. So in case vessel has different fuel oils to comply with emission standards, there shall be written procedures how fuel oil changeover should be carried out. Changeover should allow sufficient time for the fuel oil service system to be fully flushed before entering SECA areas. So the details of changeover must be recorded. So nowadays we have automatic changeover valves that assists the engineers in changeover procedures. So these details shall be recorded in the Marine Sulfur Fuel Sulfur Record Book. Okay, so you just enter SECA area. Which SECA area are you entering? The date and time of entry, date and time changeover completed, the position of the ship at which changeover is completed. So you will ask the bridge for this. And then the volume of low sulfur fuel remaining per tank with a signature of the duty engineer or the chief engineer. And then the signature of the master and the date. So that is how you put data in the Marine Fuel Sulfur Record Book. Okay, so fuel oil tank management. So last chapter 2-1 regulation 26 paragraph 11 requires that for each fuel type there shall be 2 service tanks with a capacity of at least 8 hours for operating main engine at MCR and normal electric load at sea. So these are for ships constructed since 1 July 1998 onwards. So usually on board we have HFO service tank, capacity of at least 8 hours, for main engine, auxiliary boiler for the 3. And another tank for HFO service tank and for MDO tank. So another equivalent arrangement is 1 tank for HFO service tank and 1 tank for MDO service tank. So okay. So you can also have this one set up 2 HFO service tank and 2 DO service tanks. Another equivalent arrangement is HFO service tank with MDO service tank 4 hours and 8 hours, and another MDO service tank 4 hours for main engine. So 2 4 hours is equivalent to 8 hours. So a sample diagram on ship. Okay, so we have bunker tanks, DO, HFO, MDO, and GO. So MDO is marine diesel oil and GO is gas oil. And then we have a transfer pump to the settling. And since gas oil is clean, so there's no settling, they go directly to the day tank or the service tank. And then for separation we have the purifier here, and then going to the day tank. So this day tanks should suffice 8 hours of the operation on board ship. 8 hours of operation. Okay, so from storage you go to settling, and then you go to the purifier, and then go into the service tank. And after the service tank, the fuel oil will go to a fuel conditioning system, fuel conditioning module, before going to the engine. Or if you have different types of fuel, you have type A, B, C, it goes to the settling tank and going to a purifier or the fuel cleaning system, and to the service tank, and then going to the fuel conditioning system and going to before going to the main engine. So changeover procedure. So depending on fuel oil tank management, calculation needs to be made for time needed to complete changeover procedure. So if settling and day tank needs to be cleaned, this may take days. So drain settling tank and fill up with low sulfur fuel oil and let it rest for 2 days before operating purifier. So flow through method may be used to clean day tank. So pump 3 times the capacity of LSFO into a day tank to get exchange rate with HSFO of more than 95%. Okay, so changeover procedure. Changeover from high viscosity fuel to low viscosity fuel means lowering the temperature. So to prevent the thermal shock or gassing, so injection equipment needs protection against rapid temperature changes to avoid gassing of fuel, which may lead to loss of power, since it will affect our injectors if there is gas in the fuel injector. So changeover should be carried out at low load. So you slow down the maximum continuous rating from to 25 to 40%, and then fuel temperature gradient should not exceed 2 degrees Celsius per minute. So every minute, every time you return the changeover valve, you should always remember a 2 degrees Celsius change in temperature per minute. So that's to prevent the gassing of the fuel. Okay, so changeover from low viscosity fuel to high viscosity fuel means increasing temperature. So if you will increase temperature, extra care should be taken as warm fuel will flow to cold components. So material will expand slightly. The fuel pump plunger will warm up first as barrel contains more material. So decrease in clearance, risk of seizure increases. So the fuel pump might be damaged. So these are the HFO MDO changing valves. This one is the changing valves, and this can be controlled automatically using this pneumatic system. So from water trap filter reduction valve, reduce the pressure, going to a automatic drain here, a safety valve, and then safety valve, not a drain. Relief valve or safety valve. Then we have a control main valve here, and then a 3-2-way valve, solenoid operated with spring return, controlled via the valve control box. So this can be operated electrically on automation via PLC maybe. You can also do that. And then here's the valve which will do the changeover. So you can also do the manual way of change over the fuel, or if you don't have this mechanism. Okay, so MARPO Annex Regulation 14.8 to 13 use fuel oil sampling. So verification by authorities if compliant fuel is used on board. So we have a sampling point to be fitted downstream of in-use fuel oil service tank, as close as possible to the machinery. So be clearly marked, described in piping diagram or other relevant documentation. So another diagram. So here are your tank, here's your engine. So the sample, fuel oil sample position is here, nearest to the engine. So ships may be fitted with equipment alternative fuels or compliance method used as an alternative, which are at least as effective in terms of emission reduction as required by Annex 6, including Regulation 13 and 14. Okay, so let's go with the exhaust gas cleaning systems. So conversion from sulfur content in fuel to SOx emission in exhaust gases. So SOx emissions are derived from the sulfur content of the fuel. So similar for the CO2 emissions. So the SOx or CO2 ratio gives a clear measure of the sulfur content of the fuel. So fuel oil sulfur content, percent mass per mass, and emission rate, sulfur oxides, carbon dioxide, sulfur dioxide and carbon dioxide, percent of volume per volume. Okay, treatment processes of SOx. So systems can be divided in, we have the wet exhaust gas cleaning system and the dry exhaust gas cleaning system. So the wet exhaust gas cleaning systems have three types: the open loop scrubber, closed loop scrubber, and the hybrid scrubber. Okay, so the open loop scrubber is a once-through process. Seawater is used for exhaust gas cleaning. So seawater is sprayed on the top of the scrubber. So after treatment, water is discharged back to the sea. So the wash water is is delivered into the treatment, and the treated water can be discharged at sea, and the separated residue will be put in another container. So after treatment, water is discharged back to the sea. The natural chemical composition of seawater is used to neutralize the results of SOx removal. So here is an chemical balancing of the open loop scrubber. So your SOx emission, or sulfur dioxide, plus H2O is converted into another substance, and it can be discharged at sea. So on average, seawater has salinity of about 3.5%. Okay, so for closed loop scrubber, fresh water treated with alkaline chemical, sodium hydroxide, is used for exhaust gas cleaning. So here is a clean fresh water treated with a chemical here, and then there's a pump going to a cooler and then sprayed on top of the scrubber. So if exhaust goes through the shower, so it will be cleaned, scrubbed exhaust gas, and then the that water will go back to a process tank, separating the dirty and the clean. So the clean water can be reused, while the dirty one will be removed and put into a separated residue, and the clean water can be discharged overboard, or you can put it in a holding tank. So majority of wash water is recirculated. Small quantity of wash water is bled off to treatment plant before discharge at the sea. So here's a chemical analysis of our closed loop scrubber. So scrubbing media is fresh water dosed with sodium hydroxide. Okay, the hybrid scrubber is a combination of the open loop operation and the closed loop operation. So in open loop mode, hybrid scrubbers use seawater. So seawater is used in open waters where alkalinity is high enough. Chemical addition is used in enclosed waters to avoid discharges do not affect sensitive areas with little water exchange. So while in closed loop operation, in closed loop mode, hybrid scrubbers use seawater or fresh water depending on system design. So that's how hybrid scrubber installation of hybrid systems on board Transfenica vessels. So these are the pumping fresh water or seawater up to the scrubber. Okay, so this one pump going up, and then there's tanks, circulation tank, cooler, etc., and monitoring equipment before discharging back to the sea. Okay, so we have here a video of Alfa Laval. So it's not playing. So this is a alpha level scrubber video. Okay, let's go continue. So wash water. So most exhaust gas cleaning system use water to remove SOx and particulate matter from the exhaust gases. So wash water should be monitored on following parameters: the pH. So if the water is too acidic, it must not be discharged overboard. So we have to neutralize first the acidity. Polycyclic aromatic hydrocarbon, PAH. If the hydrocarbon is too much, so we need to do something. And turbidity. So the cleaner the water, so the cleaner you can see the water, the better. If the turbidity is high, so we should do something. Okay, so monitoring instrumentation. So we have a monitor here. Okay, pH. So the maximum difference between the pH of the wash water inlet and outlet is set at 2. When the vessel is stationary, the pH at the wash water outlet should be no less than 6.5. So this is another pH and density monitor unit on board ships. We have the temperature, density, and the pH. So it should be not less than 6.5. So 6.8 is good. So not less than 6.5, not too acidic. Okay, we have the polycyclic aromatic hydrocarbons, PAH, are a large group of organic compounds with 2 or more aromatic rings. So PAHs are elements in fossil fuels and are also produced during incomplete combustion. So they are toxic and are part of the PM, which should be removed from the wash water. So continuous pH monitoring must ensure that the treatment of removing PM is effective. So toxic pala siya, so kailangan nire-remove siya at hindi siya, it should be removed and it should not be discharged overboard. Turbidity. So turbidity here, 0, is a measure of the degree to which water loses its transparency. So the more total suspended solids, the hazier it becomes. So combined with PAH, turbidity measurement is an effective means to monitor the removal of PM from wash water. So there are different designs for wet scrubber types. So we have here the spray open tower, we have the cyclonic, we have the packed bed, we have the wet bath, the bubble plate, and the venturi. So depending on the manufacturer, which type of design of wet scrubber type will they choose. Okay, so materials for wet SOx scrubbers. So usually the warm acidic seawater at pH 3 corrodes ferrous and non-ferrous metal. So to ensure long service life, alloys like stainless steels, titanium, or non-metallics glass reinforced epoxy are used in our scrubbers. So for 2021 guidelines for exhaust gas cleaning system, scrubber guideline, rules for testing, survey, certification, approval, and monitoring. So differentiates between EGCS according Scheme A and Scheme B. So for Scheme A, ECGS SOx, unit type, approval, and certification. Scheme B, continuous monitoring of SOx emissions. And this is a sample Scheme B continuous monitoring SOx. So this is a sample continuous monitoring printed report. Okay, the malfunction of EGCS. So we have here a troubleshooting guide or a flow. So IOMA document MEPC 1 Circ 883 revision 1 states any EGCS malfunction that lasts more than 1 hour or repetitive malfunctions should be reported to the flag administration and the port state administration, along with an explanation of the steps the ship operator is taking to address the failure. So just follow this contingency plan. So we have also for dry scrubber. So they use a granulated calcium hydroxide. So operates at high temperature, removes both SOx and PM. Is not commonly used on board ship. So not commonly used because of the you will be holding a granulated calcium hydroxide on tanks or on ships, and it is um, not that easy to do. It's heavier, and the space is on board is limited, and so there are many things that you must consider if you want to use the dry scrubber. In for wet scrubber we have seawater all over the ship, all around the ship. We have fresh water also, so you can use it. But for dry scrubber, it's not really used on board, but it can be used also. So the ban on the use of open loop scrubbers. So scrubbers, a false solution to the IMO sulfur cap, as they say, but since introduction of open loop scrubbers, more and more coastal states and ports worldwide are banning the use of these scrubbers. So unclosed articles are used to support this claim. So because they don't want the the water or chemicals to go into the sea, into their territory. So this is a pie diagram. So 1% of the ships are using closed loop, 70% use hybrid, 1% unknown and dry, and the other 81% is open loop system scrubbers. So to address this, maybe it's good to upgrade your open loop scrubbers into hybrid. So the ban of the use of open loop scrubbers in these areas, we have for this green ban, and for this one red orange is a restriction. So Brazil is a restricted area in some other parts. China is a banned area in using open loop scrubbers. These are the other ones: France, Belgium, Germany, Romania, Portugal, Estonia, Ghana, Saudi Arabia, Egypt, Turkey, Kenya, and Mozambique. But use open loop scrubbers in China, Hong Kong, maybe this is Hong Kong, or this is also part of the China, Singapore, Malaysia, and California. Brazil, restriction in Brazil. Okay, so NASA study evidence that sulfur regulation reduced air pollution from shipping. So less sulfur emission means fewer aerosol particles released to form detectable ship tracks. Lowering the sulfur content has weakened the masking effect, effectively giving a boost to warming up the seawater. So the likely side effect of the 2020 regulation is an increase of global temperatures of around 0.05 degrees Celsius by 2050. So 70 years of daytime images. So fraction of low clouds belonging to ship traces. So these are the emissions from ships, as you can see. An anomaly of ship track density in 2020. Low clouds. Okay, so we are in an ECA. Low sulfur matches, please. Okay, so that ends our part 1 of this video. So I hope you learned something, and see you on our next video. Up next, nitrogen oxides, or our next video will be about nitrogen oxides. Thank you so much, and see you back on our next video.